So this talk is about real options. I want to point out, because some people probably have seen Chris, Matt's, and Olaf's presentations before, they gave me their presentation and I have permission to use their slides. And this is Chris Matz's personal motto. So I'm just kind of going with that. So the talk is largely about how we make decisions, right? And this, I think, is maybe the opening part for it, the part that I'd like maybe you guys to remember, which is we always need to be coming back and taking a new look at the work that we're doing and looking at it as from a beginner's mind as opposed to from an expert's mind. This way of questioning and opening up our options is a much more effective way of working. And so we always need to be looking at the first steps and seeing what options we have. So this is, how many of you out there know that this is an hour-and-a-half long talk? Most of you, very good. Okay, so at 50 minutes there will be another set of talks that open up. If any of you guys want to go to some of the other talks after 50 minutes of me, I will not be offended. This is the general shape of the talk, which is, what problem are we actually trying to solve with real options? Theoretically, what might we do about that problem? So some theory, some practical application of real options to the real world, and finally some principles. So what's the problem we're trying to solve? What is the problem with decision making in organizations? So, you know, the most obvious problem is that we have just massive amounts of uncertainty in our industry in particular. And one of the things that we're paid to do is to consume that uncertainty in a relatively safe way and produce value. And so the way that we do that is largely based on, currently is largely based on a couple hundred years of different decision theory, right? And decision theory largely, I think, kind of starts out with just the definition of what decisions are, right? So in particular, decisions are about this, that have this quality to them that are about settling something or agreeing on something. So there's some sort of conflict, and we want to resolve the conflict. So we want to settle a dispute. That's what we're doing when we're deciding something. But in particular, the root of the word actually is this, which is to cut off, which literally means to make a final statement, right? So most decisions are about finality, right? And really, because humans are particularly bad at engaging in uncertainty, decisions are largely an attempt to reach closure, right? So they're an attempt to make us feel like we can, we've decided something, it's done, it's over, we don't have to think about it anymore. And the result of this type of decision making is a commitment. It's a commitment to do something, a commitment to finish something, right? So there's some problems with that, but the first thing that we would do with that type of model is we would make something we call the rational actor model. So if we look at the way that decision theory works, we make all those assumptions that the idea of a decision is to come to a conclusion, and then we say, if we're coming to a final conclusion, then we better be very rational about how we achieve that final solution so that we don't have to undo that solution. Does that make sense? So we create a rational actor. And a rational actor is roughly someone who has perfect access to all the information, always acts in his best interests, and is purely rational, mathematically rational, right? And if we can assume this, then what we can do is we can look around our organizations and find the most rational people, the people who have the most information, who have the best math skills, all that type of stuff, and we promote them. And then as we promote them, the next thing to do is obviously to funnel as much information to that person as possible so that they can make the decisions, right? So whenever there's any uncertainty in the organization, the goal in this model would be to funnel information into a central point to the most rational actor, right? So this is all based on what we call rational choice theory. And rational choice theory is very simple math. There are pros, there are cons, we measure them, and we succeed. Now the problem, of course, is that humans aren't very rational. And they're exceedingly unrational, often. This doesn't mean that we can't function or we can't act in the face of uncertainty, but we do need to acknowledge that humans aren't particularly rational, right? And so Herbert Simon first came up with the first version of, if you have a rational actor, which is the basis of most economic theory about decision making, he came up with a concept he called bounded rationality. And bounded rationality basically says these three things, which is actors, people who are making decisions, have limited access to information, they have limited cognitive abilities, and they have a finite amount of time to make decisions. Make sense? So I can't have all the information in the world in my head when I'm making a decision. I might not have perfect information. I might be misinformed, A. B, no one has infinite cognitive horsepower. And C, we always have to make decisions within a certain time frame. So these three things bound our rationality. They make it so that we can only make what he calls satisficing decisions. So decisions that are as good as we can make for the time, information, and cognitive ability that we have. So in our community, we also like to talk a lot about biased rationality. So these are subtly different. So this is Kahneman's concepts of rationality. So Kahneman has rationality which is called biased rationality. And actually, so this is a different form of problem with the rational actor theory, right? So the bounded rationality kind of assumes that most of the stuff is right, you just have limited access to certain qualities, time, rationality. Biased rationality actually says that the way that you make decisions is inherently flawed and cannot be, you can't get away from these biases, right? So you're stuck with them, right? And so in particular, they're measurable deviations from rational judgment. So in other words, if you were a space alien who had perfect rationality, you'd come down and you'd look at human beings and you'd say, you guys are insane, literally not sane, because you make decisions that don't make any sense. They're not rational, right? And we can measure these, and they're influenced by both our cognitive abilities and our motivations, right? So, part of all these problems is that, kind of entangled in all these problems, is this, which is that most rational actor theory requires a deep understanding of probability. And most human beings do not understand probability. They don't understand what it means. It just inherently, lack of education is a big problem around probability, I find. But also, because of biased rationality, that actually, even if you understand the probability, you still are influenced by your biases to go against what probability would tell you to do. So, this kind of gets us to a point where we need to understand risk, right? So why do we need to understand risk? Well, there's no decision without risk, right? So decisions without risk are just like flipping a coin, doesn't matter, right? If you're making a real decision, you're choosing one thing, and you've chosen not to do another thing, then you've taken a risk that you've chosen the right thing, right? So there's different kinds of risk, and they're important to understand so that we can have a better discussion about them, right? So the first one is just qualitative risk, right? So qualitative risk in the form of when you get in a car, there's a risk that you will be ejected. It's just a descriptive risk, right? Another type of qualitative risk is what the cause of the risk is, right? So this is just, again, descriptive. Drunk driving is a qualitative risk. If you drive drunk, you risk getting in an accident, right? So this is also a descriptive form of risk. Then there's quantitative risk, right? Which is the probability that an unwanted event may occur, right? And this is largely what we mean by rational actor theory. This equation here, which is the expected outcome, the expected value, right? And all it is what's the probability that that event will happen, and what is the cost of that event happening? That's basic rational theory, right? So that's one form of qualitative. And the other one is, quantitative, and another one is quantitative, which is just a statistical expectation that you might incur a risk. So if you smoke, you increase your chance of getting lung cancer by 50%. That is a type of risk. Right? Does everybody, so there's those 4 different kinds of risk that we all use the one word to mean 4 different things, right? So, there's a final problem with risk and with basic understanding of probability, which is this called Knightian uncertainty, right? And so what he says is that there's actually 2 different kinds of risk that we mix together. One is risk, which is what I just described to you. Quantitative risk, right? So the risk that something will happen that you can measure. And the other one is uncertainty, which is the risk that something will happen that you can't measure. It's uncertain, right? So the subtle difference here is important. So here's an example of how the differences work, right? So here's 2 bets that I will give you guys, right? One, I will give you $100 if you take the first bet. And 2, I'll give you $200 if you can call a coin flip. Who wants A? Okay, who wants B? All right, so who doesn't care? Very good. So the only rational actors in the room, in theory, are the people who just raised their hand at the last one. Because according to expected value theory, there is no difference between those 2 bets. Rationally, there's no difference. Doesn't matter what you do, right? So that is the people who raised their hand for the first bet, they have something that we call risk aversion. People who raised their hand for the second bet have something we call risk affinity, right? And these 2 different things are the ability for human beings to either engage in, I don't want to take any risks, or be very fond of taking risks because they like the rewards. There's actually a feedback loop that happens with taking risks. If you take a risk and it pays off, you're more likely to take another risk. This is why you go in a casino, they'll give you some cheap, high probability games because those are just hooks to get you into the big games, right? So, here's another one for you guys, subtly different. This is a little bit harder to understand, so pay attention. I have a hat that contains 30 red balls and 60 other balls that are either black or yellow. So you know I have 30 red balls. I have 60 other balls that either could be black or yellow. The balls are very well mixed, so you can't figure out which one's going to come out. There's no rigging of the game. And you'll be given a choice between 2 gambles. The first one is this. I'll give you $100 if you can draw a red ball, or B, I'll give you $100 if you can pick a black ball. Who wants A? 1, 2. Who wants B? 1, 2, 3. Who can't decide? Very good. I like you guys. You're falling for the trap. All right, so here's another one. I'll give you $100 if you draw a red or a yellow ball, or I'll give you $100 if you can draw a black or a yellow ball. Who wants A? Got 2. Who wants B? Got a few more. Okay. Who can't decide? Okay. So both of these examples are something that we call ambiguity aversion, or the Ellsberg paradox. Ellsberg actually, anyway, so ambiguity aversion is this. So risk aversion is, I know the probability of 2 different things, and I'm risk averse, so I'll take the one that feels less risky, not really less risky, but I'll choose based on 2 known probabilities, right? Risk aversion. Ambiguity aversion is that people will choose the thing that has risk that they can measure over the thing that has unmeasured risk, or they will fail to choose at all. Ambiguity aversion. So this is the classic thing where you go into a meeting and one guy has a project plan and the other guy has a great idea, but no project plan. And the guy with the project plan gets all the resources, right? Because this thing may not be a better bet, but it feels like it's a better bet because it's more real. It's less risk involved in it, right? Because it feels like it's been quantified. So Ellsberg paradox is this. It's the fact that you will choose to take a 50-50 risk over an unknown risk, right? So this gives us a couple different ways of when we are faced with making decisions and how those decisions face us, right? So the first one is decision under risk, right? So decision under risk is like making a decision about the mean time between failure of a component based on its previous performance, right? So if you've got a hard drive, you can figure out how much risk you want to undertake, right? How close to that mean time between failure do you want to get? How much redundancy do you want to build into the system to avoid that, right? Now this one in particular is interesting because it also has another way of influencing you, which is called Prospector Theory. So this is another Kahneman thing. And basically what Prospector Theory says is that the greater the losses, the less, the more risk averse you get, and the greater the benefits, you actually have less likelihood of increasing your risk affinity. So it looks like this, right? Risk seeking over low probability gains, risk averse over low probability losses, risk seeking over high probability losses, risk averse over high probability gains, which is very weird, right? So this last one in particular means that you intentionally choose not to engage in those things that could give you the highest payout because they feel riskier, which is very strange, right? So the next one is decisions under uncertainty, which we will largely be talking about today. And these types of things are things like, should I trust an expert's estimates? And how should I make decisions about that? And one of the interesting things about decisions under uncertainty is that almost always we should expect late binding information. And we need to update our decisions pretty frequently because of some of the other stuff that we'll get into. Finally, Hubbard has a book that helps people make better estimates, and that's an excellent way of starting to make better decisions under uncertainty. I highly suggest it. So, the last one, which is the one that most people use, is decisions under ignorance, which is just saying, screw it, whatever I feel like today, right? Now the problem with this one is that you can make decisions by your gut, but there's a warning, which is that your gut has shit for brains. So you want to be careful, right, making these types of decisions. So all of these things, there's a nice heuristic for all of these different things I've been talking about, which kind of helps you think about how people think about these things, which is, this is the rational way to make decisions. If I'm going to make a decision, I'd like to be right. Yes? Everybody would like to be right. The second thing is that if I'm not right, I'd like to remain uncertain. And the final thing would be, I'd like to be wrong, right? Like, this is the worst outcome. This is an uncomfortable outcome because people don't like being exposed to ambiguity, but this is the one we want. Now the problem is that when you actually observe people, they tend to do this. They actually flip this. They'd rather be wrong, they'd rather make the wrong decision than remain uncertain, right? So in a large amount of organizations, decision makers are deciding to go forward because they feel like it's too uncomfortable for the organization to remain uncertain, or they feel like if we don't make a decision, nobody will do anything. And if nobody does anything, we're just going to go out of business. So we got to make some decisions, even if it's the wrong decision, we're going to make it, right? So that is kind of some of the cognitive and problem areas around risks and things like that. So let's look at a different problem. This is what I call the problem of expertise. And so this one, usually I can get people to understand this one pretty quickly by doing it like this. You've got a boss, and he doesn't really know what you do, right? Everybody pretty much kind of like their boss doesn't really get them. Like, I know things my boss doesn't know. Like, so this is a problem because the experts actually in most organizations nowadays know a lot more than their bosses do, right? So it used to be if you were going to be a master goldsmith, you could know everything about gold, everything about smelting gold, everything about making rings. You could know everything. And so when you had an apprentice, you could teach them everything, and specifically, you could watch them and tell them what they were doing right or wrong all the time, right? So So I've been at CTO for longer than I care to admit. I can generally get an idea whether or not an Oracle DBA is generally going in the right direction or not, but I kind of got to trust them that they're doing the right thing sometimes, right? Because they have more expertise than I do. I didn't spend 20 years becoming a DBA. I spent 20 years becoming a CTO. So this problem is the problem that expertise is based on experience. You have to do the things to become an expert in them. You can't just give them to me, like give me your expertise. It's not transferable, right? So the other version of it that people don't tend to get, right, is that this tends to go across organizations too. So the DBA and the Java guy don't necessarily have the same expertise, and they sometimes can't transfer information back and forth between them. That make sense to everybody? So the problem of expertise is you've got pockets of experts in your organization, and they're not directly swappable. You can't just assume that because one human being and another human being exists, you can just move them around, right? Kind of like the nasty use the word resource for human problem, right? So can you guys see maybe what the problem with centralizing information is if you think about the problem of expertise, right? These guys down here know how to make the decisions, really, about specific problems, like whether or not we should reboot the Oracle database or just reformat it, whatever. They know the problem. This guy doesn't, but in a lot of organizations, in order to figure out a mission-critical problem like that, you would have to go up 3 levels and get permission to do it, right? It's because we have this tendency to want to centralize information again. So David Snowden has this list of kind of problems that we have with moving information and expertise around organizations, right? So, and I think they're excellent because they really help you think about this particular problem, which is things like knowledge can only be volunteered, it cannot be conscripted. In other words, I can't force you to tell me what you know. I can only ask you, and you can tell me or not. We only need to know we only know what we need to know when we need to know it. So this is a thing where, like, I don't know, for me, when I program, if I'm in the IDE, I can do the programming, but if you make me do it on a whiteboard, it feels really weird. It feels hard to do because the context of being in the IDE, it's like my space that I can think in, right? I've been doing it for so long. If you take me out of that particular space, it makes it harder for me to know things, right? Everything's fragmented, so the way that we move information around nowadays is very fragmented. We send people tweets and emails and things like that that are very small and disconnected. So you need to know the context in order to unpack that fragmented information. If you don't know the context, you have no clue what's happening. You follow some random Twitter guy that you don't know. It's really hard to follow conversations. But if you know people, very easy, right? The way we know things is not the way we report we know things. So even if you can get somebody to volunteer the information they have, they often don't really know how they know that thing. They can't explain it correctly, which is quite interesting. And finally, we always know more than we can say, and we will always say more than we can write down. So in other words, moving information around organizations, incredibly painful. Very, very difficult to do this, right? So this idea that decision-making is about collecting the right information and giving it to the right person to make the decision is inherently flawed. Does that make sense? So information and skill and knowledge are embedded in networks and relationships. Individuals, instead of owning information, attract, translate, and know how to and where to access information that emerges in the networks around them. So you can't move information, basically. That's the next problem with kind of rational actor theory. Okay, so now this is the final one, and then we'll get into some of how do we maybe solve this stuff. The first thing is that as we are engaged in solving a problem, the more time that passes, the more information we get, right? So there's 2 ways we get information. One is that it could just come to us. So random events happen, the news, we read about it, we know new things. The other thing is that we could go out and actively pursue new information, but we have this one problem, which is that as we go forward, we get more information. So also as we go forward towards some sort of deadline that we have to achieve or some sort of terminus of our project, we have less and less options, right? So all options have different sizes. At some point, you have to start and execute on the option. If you don't execute on it at that point, you lose the opportunity to do that option, which means you have less options. So as you get closer and closer to a deadline, when you have 4 weeks, you have lots of options. When you have 2 hours, you have very few options, right? So you have this weird thing that's going counterbalancing each other, right? Which is, one is the longer you wait, the more information you get. The other is the longer you wait, the less options you have. Does that make sense to you guys? So the result of this is what I call the crap curve. So the crap curve is, if you go to most code bases, I guarantee you you can figure this out, which is, this is all the code that was written within the last day of a sprint. As people had less and less options on how to correct the code and fix the code and make the code, right, work, they made bad decisions in order to get done at the end of the sprint. Now, some people in good organizations would just go back and refactor that, or they would have an honest conversation about not being able to do the work. But this is prevalent, right? Which is this, that is the problem that is caused by this kind of moving, countervailing information and options, right? So the other one that I see in a lot of organizations is the box packing algorithm. So if you get less and less options as time goes by, one of the things you might want to do is not have your sprint completely full, because you might want to have a little bit of space at the end so that you can actually execute some of the options. But most organizations instead do the exact opposite, which is they figure out how big their sprint is and they make sure it's completely full of work so that they have no options. They can't switch out what they're doing, right? Make sense to you guys? And then the final one that I see in organizations is this idea, which is go faster and do more, right? Now, the problem with this is that if we look at decisions as being engaged in uncertainty, right? So we don't know if this is going to be good or bad. This is literally just telling your organization to take more and more bets. Do you guys think it would be a good idea to send your employees to a casino and say, bet as fast as you can? Because that's what this argument is, to some extent, yeah? So, let's move on to kind of how we might think about solving some of these thorny little issues. This is a very basic decision-making model, and I'm going to point it out mainly to point out what we're actually going to focus on, right? So all models are wrong. Decision-making is not a linear process. It is a convoluted, twisty thing. But here's the general steps. So you identify a problem, you generate alternative solutions, you evaluate and select those solutions, and then you implement them, right? So what we're going to talk about for the next hour is real options, and that's basically this. How to evaluate and select what you're going to do, right? That's kind of what we're talking about. Now, identifying the problem, if you guys are interested in that part of solving problems, you should go read about design thinking. It's great stuff. If you are interested in generating alternative solutions, you might want to read about generative ideation, deviant thinking, and divergent thinking. And finally, implementation, which is all over the place: Agile, XP, Kanban, Kata, DevOps, right? So this is the type of stuff that you go to look for those parts of it. So we got a lot of uncertainty, and we're trying to figure out how to make decisions. And so one of the things that we can note is that information is the resolution of uncertainty. So we want to have information. Information will reduce the amount of uncertainty in the system and allow us to make better decisions, right? And so one of the interesting things about Kanban systems and especially knowledge work in general is that it's largely about an information arrival process. We actually don't know what we're going to do at the beginning. We kind of find our way through it. Does that make sense? And so we as knowledge workers, we engage in a process where part of what we're doing is creating information, making decisions based on that new information, right? So just to really quickly go over David's stuff last night. We have an ideal delivery date. If we miss it, the cost of missing the delivery goes up. This is the cost of delay. Does that make sense to everybody? It's good? So the same way that I earlier said, you start with lots of options and you get less options, this green line's kind of like the ideal curve of consuming options, right? So we consume options. By the deadline, by the ideal delivery date, we have no options left. We don't want any options left on the table. We want to have consumed them all. That make sense? And so we have this last line, which is that in order to consume those options correctly, we need to get the information that we need to make the decisions about those options. Follow me? So this is kind of like another curve of how we would like the information to come into the system. Now, this is largely what I see happen in many organizations, which is the information to make these decisions comes after the deadline, right? This is problematic, obviously, because it means that you're making suboptimal decisions. And so what I want to call this is uninformed speculative risk as a cost of delay. Anything inside of this blue curve here, not this part, but this part, is in essence a cost of delay of not having the information that you needed to make good decisions, right? And so what we want to do is move the information gathering forward, not all the way to the beginning, but we don't want it to be after the deadline. We want it to be before deadline. So there's one more set of little weird theories that I need you guys to understand in order for this to work. The first one is that there's a concept called aleatory uncertainty. So aleatory uncertainty is the intrinsic randomness of a phenomena, and it cannot be reduced. In any system, there is a base set of uncertainty that we can't get rid of, right? And then there's epistemic uncertainty, which is uncertainty that can be reduced by getting more information, right? And we need to be able to differentiate between these two when we talk about what we're going to talk about for the rest of the day, because if we try to apply real options theory to aleatory uncertainty, we will just be wasting our time, right? You have to be able to figure out whether or not the uncertainty you're trying to reduce by getting information is actually tractable. It's something that you could actually reduce versus not reduce. And just for fun, there's also this, which is kind of the turtles all the way down thing, which is the trick here is there's uncertainty about what kind of uncertainty you're engaged in, which is also kind of fun. But anyway, and a pro tip for people who are human systems thinkers, human error is aleatory. You cannot reduce it completely. There's just, in any system, if there's humans involved, there is a base error rate that you cannot get rid of. So any system design that you make that has humans in it, that has as a base assumption that humans are infallible, will absolutely fail. So, in the 1990s, there was a pair of professors named Dave Kirsch and Paul Maggiello, and they were watching people play Tetris. You guys all know Tetris? Anybody not know Tetris? Okay, so what they noticed was that relatively good players would spend a lot of time looking down here, looking at the piece, and then aligning the piece to fit in the spot. Does that make sense? So they kind of look here first, and then they go up here, and then they look down, and then they would put the piece in there. Very, 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 very good players would do something very strange. They'd just look here, and they'd twiddle it. They'd spin it around very fast. And what they theorized about this is what they call epistemic versus pragmatic action, right? So their theory is this. The very good players spun the piece to reduce their cognitive load. They were spinning the piece to kind of be able to look at the entire screen at the same time and look and see which one fit. So they weren't calculating what the spatial dimensions needed to be in order to put it in there. They were literally just looking at the whole screen and spinning until they were like, oh, that one fits, and then they would drop it in. Does that make sense? So it is this epistemic action versus pragmatic action. The epistemic action is action to learn what to do versus pragmatic action, which is action to achieve an endpoint and a goal, right? So the good players used pragmatic action. They looked, they analyzed, and they put stuff in. So they achieved a goal. The very good players used epistemic action, which was what might appear to be wasteful action. They appeared to be wasting their energy. They appeared to be doing something that didn't make any sense, but they were doing it in order to understand or get information by lowering their cognitive load. Make sense to everybody? So what I'd like to propose to some extent is that really in most businesses we don't need to decide to commit. We need to decide to act. Does that make sense? There's a subtle difference there. But all we need to do is convince people to do something, and that is a good action. We don't need to always arrive at a commitment in order to act. And I want to be clear about this because of the difference between epistemic and pragmatic action. In epistemic action, all we need is for you to act in order to learn. In fact, you could dispose of a lot of the stuff that you create because the only reason you did it was to learn. But we almost always act as if what we're doing is pragmatic action, which is define a goal and define all the steps to achieve that goal and make sure you do all those things, right? So as long as we know at the very beginning of our project exactly what we want to build, that's great. But often we don't because what we're doing is an information arrival process, and it really involves a lot of epistemic action and not a lot of pragmatic action at first, and that is how we can start shifting here. This is largely about engaging in epistemic action. All right. So one of the ways in order to help people make decisions to act is to bound uncertainty. So instead of eliminating uncertainty, well, one of the things we might want to do with people who are uncomfortable with uncertainty is just bound it. Say this part's uncertain, but this part's clear. Right? Does that make sense? So it might be things like how long can you engage in epistemic? Right? How long can you before you have to do pragmatic? What are the boundary conditions of allowing you to engage in uncertainty for a long period of time before you have to convert over into very pragmatic action? And that leads us to real options. And this is the theoretical kind of stuff that will allow you to engage in this stuff, I think. So real options is largely based on options theory from the financial markets. And Chris Matz and Olav Masson looked at it, and they tried for a while to figure out how to use the math directly in order to figure out how to value options, how to value the things that you might do in a project. And what they figured out was that the math involved had a set of assumptions that could not be assumed of knowledge work. So you can't use the math. But what they did do instead was they converted the math into a set of heuristics. So these are those heuristics. Options have value. Options expire. Never commit early unless you know why. Now, for me, there's a very subtle couple things in here that you need to understand. And the first one is this, that originally when they started talking about real options, one of the things they would say pretty frequently was that real option was about deferring decisions. Does that make sense? Like deferring decisions. So one of the reasons I want to point out to you guys that deciding to act is different than deciding to commit, right? So that in fact, this isn't about deferring decisions, it's about deferring commitments, and it's a subtle difference, right? So never commit early unless you know why, and I'll explain what we mean by commitments in a minute. The options expire part, that's the part that I said about bounding uncertainty. So if you have an option, it's an open set, you can think of an option as a set of uncertainty that's kind of open still. It's not committed yet. And so you have to put an expiry on it. So you could set a set of conditions that say, when these things happen, this option is no longer valid, right? So the options expire. And finally, options have value. So I'll explain a bit more about how options have value in a minute. Or I'll explain right now, sorry. So this is why options have value, right? Which is that if the time it takes you to recover is greater than the time you can survive, you'll die. Does that make sense? So if you have one option, and you run out of time on that option, you have no other options, you just die. So options have value because when you engage in something, the first thing you do is say, what other options do we have? And which option do we need to exercise first? And we can defer all the decisions on the rest of them. We only have to worry about the one that's going to fire first and deciding whether or not we're going to commit to that option. If we run out of time and we have to commit to an option, then our survivability is in question. So this is an exercise for you guys, because you guys are getting tired, I can tell. So what is optional? Okay, so I'm going to ask you guys to raise your hands. It'll work better if you actually do raise your hands. So what is optional? For me, was it an option to come give you guys a talk today? Is it an option? You guys are so kind. I didn't have to. I'll leave now then. No, I think it was a commitment on my part, right? I committed to I actually signed a contract. They could have been mad at me, right? How about for you guys? Yes? Did you have delegated? Huh? Did you have delegated? I could have. So I could make it optional. We'll get there. But for you guys, was it a commitment or an option to come see me talk? Option, right? How about this? I bought a ticket to go to Lean Agile Scotland. This isn't really my ticket for that, but I did buy a ticket recently. Is this a commitment for me? Option, right? Is it a commitment for British Airways? Yeah? They like to think it's optional, I think. But it should be contractually a commitment on their part. How about a hotel? So I have a reservation here. Is it a commitment for me to be here? Is it a commitment for the hotel to have a room for me? Yep. So one of the interesting things about hotels recently, I don't know if you guys have noticed this, but they figured out that this is actually an option, and they'll charge you for it, right? So they will say to you, I'll give you a room for $100 a night, and you can come or not come, and you can cancel at the last minute if you want to. It's $100. But if you commit to coming, I'll give you the same room for $80. So they're pricing the option, right? So they've given you a price, $20, converts it from a commitment to an option. Make sense? So the shifting stuff from commitments to options is about making things reversible, right? So making it so that you can go back. And that's a subtle difference, but it's important. So in financial theory, they call it an obligation versus a right, which I think is a little bit more clear than a commitment or an option. But I didn't write the book, so they said commitment and option. An obligation is the hotel's obligation to have the room for me. A right is my ability to show up and say I want to use that room. I don't have to, it's just a right. How about this? A locked door. Is it an option to get back in after the door's locked? Is it a commitment once I lock the door I can't get back in? Huh? That's right. So the way to convert this from a commitment, I locked the door and I don't have my key, into an option is to have the key, right? So this is that idea again of when you make a commitment, you don't have the option to go backwards, but you can always try to convert commitments into options, right? So this is the basic piece of real options, which is whenever possible, you want to convert commitments into options. Whenever possible. And then you want to also keep as many options open as possible. So finally, how about this one? Blog post. When I hit that publish button, is it a commitment or an option? Anybody? It's an option? Yeah, so I think it used to be an option because you could take it down again, but now with all the blog aggregators and stuff, I think it's actually a commitment. Like you just lose control of it. So this is one of the things is that not every option, not everything can remain an optional. Once you publish some things, you can't take them down, right? All right. So let's look at some practical like applications of the theory, right? Of the stuff that we've been talking about. So I guess this is probably not a practical application. We'll still get there. This is just a little bit more theory. So everybody know like this is the classic like agile argument for risk mitigation, right? It's like don't engage in tons of risk at once. Engage in little bits of risk, right? Incremental delivery. Does that make sense? So this to me is great, but it ignores the thing that I'm trying to get you guys to think about, which is this is always incremental value, so this is about pragmatic action. Does that make sense? In most agile thinking, this is about delivery to the customer, right? So whenever you're engaged in things, you're always thinking about delivering to the customer, right? So what I'd like to shift people's thinking about this to is that some of these are pragmatic and some of them are just epistemic. They're just about information gathering, right? So this shifts the way that you engage in creating software, because if you're just doing it for information purposes, there's a high chance that you won't want to keep the results, that you want to take the results down. It shifts the way that you think about how you architect your software, as opposed to if you're always thinking about pragmatic value, you're always assuming that you've built the right thing and that it's done, and then you should build the next thing. Make sense? Okay. So that requires that we have a shift in the way we think about how we engage in these increments, right? And the way we want to engage in them is safe to fail commitments versus options, right? So the way I explain safe to fail is this. Anybody ever been inside of a Sun E10000? It's like a box about this big. You can sit down. You can bring a chair inside and sit down. It's great. Huge machine. Highly, highly, highly redundant, right? Like multiple ports for everything and power supplies everywhere. Very expensive. In fact, when you bought it, you had to buy a human being with it because there was a contract that went with it to actually have it maintained. There's also the E10000, which was, the normal servers, which were dual backplane, dual power supplies, everything, right? They cost about 10 grand, and about the same horsepower as my laptop. Now, the theory behind Sun hardware was resilience, right? So you could walk up or you could shoot it, and it would keep running because it was so redundant, right? Now, that is a fail-safe system. Does that make sense? Cost a lot of money, but it won't go down. But it's also monolithic, right? So there's only one of them. If for some reason the surrounding environment that it's in goes down, so if the server farm that it's in goes down, you lose the whole thing, right? As opposed to Google, right? So how does Google do hardware? They say something completely different, which is we're going to use highly commoditized hardware. We're going to use backplanes and chips that you can get anywhere else. And because of that, we're not going to make them redundant because they're so cheap. We'll just make more of them, right? So, but what we'll do is we will tell the software engineers they have to make a specific assumption, which is at any point the hardware that you're on could just disappear. You have to architect the software with that assumption in mind. And that is a safe to fail versus a fail-safe system, right? So the first Oracle systems on Sun, one of the assumptions was, I just spent a ton of money on that system, it'll never go down, it'll always be up, right? Versus Google, which thinks the opposite. So when we engage in kind of epistemic action, where we're trying to learn stuff, we want to adopt the second model, the safe to fail model, which is that we want to architect our software in ways that we assume that what we were doing won't work. Just the basic assumption. What we're going to put on the website is not going to work. So how would we architect the software in a way that when it doesn't work, we can take it down, as opposed to leaving it up? As opposed to the opposite way again, which is when we publish it, we assumed it works, so we never figured out how to take it back again. So do you see how safe to fail is like a option, as opposed to fail safe, which is a commitment? Does that make sense to you guys? Cool. So here's another kind of practical thing that I want to kind of change the way people think about. So I love David's talk last night, and I have stolen pieces of his slide here. So this is all the same type of stuff that I talked about, right? Which is, this is the cost of delay. You could use probabilistic forecasting to figure out exactly when you need to start. But he calls it a commitment point. And what I'd like you guys to change language to is that that is an option expiration point, right? So it's not that you have to commit at that point, it's that you have to decide whether you want to execute on that option at that point. Now, if you have other options, you may not have to commit. But if you only have one option, you're going to have to commit. And that is a subtle but important difference, right? So, given no other options, if you do not have good information, you are about to convert a speculative option into a commitment. Does that make sense? It's a subtle, weird thing, but I think it's important. Additional options, this is why options have value, may allow you to avoid speculative commitments. So you guys get like why I'm calling it a speculative commitment? You are about to make a decision that you know you don't have the information for. You've run out of time, so you need to not make that decision, but you have to make that decision if you want to hit the deadline. So if you have multiple options, then you could choose not to do that because you could wait on the other options and see if you can get the information you need for them. So here is the way that most people, I think about options, which I think is unfortunate, which is you get a list of options and you say, when will we be done? And largely what people do is they choose the one that will get done first. That's their kind of selection criteria for options, right? But this doesn't actually help us pick the best option. It just helps us pick the shortest option, right? So instead, if we look at it like this, where we slide it up against the option expiration point, and then we ask, when does the option expire, which is, this is the deadline, and how far back do we have to go before that option expires? That is the point at which we need to make the decision about only this option. So if we have other options, we can say, hey, I don't like this option, we're not going to execute it, we've done some experimentation to figure out if it works or not, but we don't have to experiment on it anymore because it's not a valid option after this point. These other two options we want to keep open, and we just have to probably focus on trying to get the information to determine if option 1 is a good option before the next expiry, and spend some time exploring option 2 so we can compare the two effectively. So the reason why I think that this is problematic is, and this is kind of a no estimates-y argument, which is fine, I think, but just to give you guys an idea, is that I think largely one of the biggest problems with estimates is that estimates really are, in the end, a combination of an estimate about duration and an estimate about uncertainty. They're two different things. They're two different numbers, right? And largely what happens is that we don't like to have two numbers involved in things, so we ask for one number. And since we don't like uncertainty, we choose duration, right? And so what we do is we convert complex things that have both duration and uncertainty engaged in each other, and we convert that simply into a duration number. Does that make sense? So I think this is largely the problem of no estimates. This is like one of the biggest problems with no estimates, is you're trying to have a single number represent multiple numbers. So the problem with that is this, which is that if you picked option 2 simply on duration, but you didn't examine how much uncertainty there is about that estimate in option 3 could actually be less time. It's possible. But you just didn't notice at all that there was a significantly high amount of uncertainty in that estimate. And so one of the things you could do is explore option 3 if you knew that it had a high amount of uncertainty in it, in order to determine whether or not you could shrink the estimate down into a good time period. Does that make sense to most people? Okay. So here's my big squiggly graph. This is how to apply real options to decisions. So you have a decision, and there's 3 possible outcomes to a decision. One is that you can make a commitment. One is that you could choose to use it as an option, and the third one is you could defer the decision, right? So a commitment, basically what you want to do is pragmatic action. You set a goal, right? And you just try to achieve the result, right? And you define the result by some success criteria. So you use BDD or TDD or whatever your favorite success criteria framework is, right? So this is largely where most people are, I think, in software engineering. This is what they're doing. And it's largely driven because somebody's constantly saying, I need you to commit, I need you to commit, right? So this is what they're doing. Now, if you choose instead to do options, what you want to do is epistemic action, right? So what you want to do is determine what information would allow you to make a better decision about whether that option should be turned into a commitment or not. And before you start, define the option expiration, right? So you just define, say, hey, how will I know when this option is going to expire so I don't keep on treating it like it's an option past the time where I would actually have to make a decision? And that I would call your expiration criteria. And the expiration criteria bounds the options themselves, which takes unbounded uncertainty and turns it into bounded uncertainty and makes people more comfortable with making a decision because they understand, oh, so you're basically saying, I don't get to make a decision now, but you've defined exactly when I will get to make that decision. Okay, I'm good, right? Feels much more comfortable. Or finally, you could defer the decision, right? You can say, I'm not going to decide about this at all, but you still want to note when the option expiration for that is so that you can go back and determine that. Now, whenever you hit an option expiration point from either of these two paths, you would go back to a decision point, which would mean you'd select a different option or you would select a commitment. Does that make sense to guys? Okay. So, other practical things. Can we identify classes of uncertainty that are more likely to be epistemic? So is there a certain class of problems that we always encounter that if we had knowledge earlier, it would be better? So this is kind of like shifting to the left there. So everybody recognize that? Anybody know what Brooks's law? Anybody not know Brooks's law? Okay, so I think this is a really interesting law, except that I think that almost everybody who, when I hear them state it, they don't state this part, right? The late part. So they basically say you can't add more engineers to a software program or it will just all collapse, right? But that's not what Brooks said. He said you can't add engineers to a program late, right? So basically, this is exactly the type of stuff that we were talking about in the early thing where we want to shift information early. And critically, because we know that it's hard to shift knowledge around, we would want to start, the expiration on being able to do this is very early. Does that make sense? So you need to it's not that you need to commit engineers to a project, it's that you need them to have the knowledge that you could later commit them to the project. Does that make sense? So watch this. This is the way this works. There's a concept called market liquidity. So market liquidity basically says there's buyers and sellers, and a liquid market is when there's more buyers than sellers. Make sense? So in a software engineering program, when there are more engineers capable of consuming the particular work that you need done, aka they have the expertise to do that thing, then you have a very liquid market, right? So you can the work will flow through the system. When you have less software engineers than you need in the market for the work that you have, then the market will clog and it will slow down. So you see bottlenecks show up in your stuff, right? And the critical part about this, I think, is that this is not controllable by WIP. You can't use WIP to constrain this, right? This is about moving knowledge early enough in your program to make sure that if you want to have the option of having another DBA on the project, that you have another DBA on the project. Does that make sense? It's subtle. And it's based on this problem of expertise. Now, that all sounds very theoretical and complicated and stuff like that, but there's a very simple way of doing this. And you don't even have to do it as a manager. You can put this on the wall. What you do is you get all of the guys in your organizations, guys and gals, to list their names across the top of a spreadsheet, and then you list down all the skills that you think you need in order to achieve this result, right? Then you get them to rate themselves from 0. God, if you let me do that, I will almost certainly break something. To 3, I could design that in my sleep and I know exactly what it's doing, right? So you get them to rate themselves. Now, the rules for assigning work in an organization that is using staff liquidity is what we call this, is this. If you are a 3, and especially if you are the only 3, you may not do the work. You can pair with somebody to do the work, but you cannot be assigned a task. Does that make sense? And so what we're doing here is very early in the project, we're trying to move the knowledge about how to do the work around the organization, which increases the liquidity of our market and the options that we have for executing later in the project. Does that make sense? Staff liquidity. Now, yes? Sorry, you want me to do the whole thing? Yep. Okay, so you list out your staff members on the top. I do this by project at the beginning of a project. If there's a project manager, you ask them, could you just generally, don't go down to I need somebody who understands, tiny bits, big chunks of knowledge. What knowledge do we need to get this project done, right? Now, list out, ask the individuals to self-rate themselves. Not you rate them, they self-rate. There's a reason for that. One of the reasons is that it may be that they want to game the system, and that's actually good, right? So people might rate themselves very highly because they're bored with this type of work and they don't want to do it anymore, which is fine. Anyway, so you ask them to self-rate, and then you look across, see the reds here? This means that we have people like here, we only have one guy who is an expert. Here we have nobody who's an expert, only people who are novices. And here we have one guy's an expert and some novices, right? So these are red because we don't have enough high skill actors in this. Now, if you can imagine, you're doing the work, right? And you get towards the end, and for some reason in the project, we've deferred making a lot of commitments, but now we get to the point where we need to execute some options, and those options are all options about making tea. If there's more than one of them, you don't have the liquidity in the market to execute on that option anymore. Does that make sense? But if you start very early in the project where somebody has to make tea roughly every day, then they would pair program on this stuff. Preferably this guy would pair with the 3, the 3 would pair with the 1 maybe, the 2 maybe with the 1, try to bring everybody up. This increases the liquidity across your staff, right? Staff liquidity, by the way, terrible. It's the Soylent Green thing. But anyway, does that make sense? Okay. Now, there's one of my favorite graphs in the whole world. I show it almost in every talk because I love it so much. This graph is called, is from a report called the seer-sucker theory. And a seer as in a foreseer, someone who sees into the future. And what this guy did was he went and reviewed a lot of people whose decisions are deterministic, like that you can determine whether they made the right decision or not. This is often like stockbrokers and stuff like that, right? And this is a relative graph, not an absolute graph. And so what this thing says is this: your level of expertise versus your forecast accuracy. And what it says is if you have no expertise, you have no experience with a thing, you have very low predictive power, incredibly low predictive power. Now, if you have just a little bit of experience with a thing, you have almost the same amount of predictive power as an expert. And in fact, he found a lot of cases in certain industries where if you were considered, especially if you were self-considered, to be an extreme expert, your predictive power went down. And it's because you stopped listening to disconfirming information. You assumed that you knew the right answer all the time, right? So if you had a stock portfolio and somebody came up with a strategy to have this curve for you, you'd invest in this all the time, right? And so knowledge, information is valuable. And this basically says, with very low levels of investment, you get very high levels of return on staff liquidity, right? You get very high levels of return on this. Does that make sense to you guys? And so staff liquidity enables a couple behaviors. One is swarming, and there's two types of swarming that I like to see in organizations. One is the classic, everybody know what we mean by swarming in Kanban. You get a blocked queue and people swarm to the queue, right? So staff liquidity increases the effectiveness of that. So if you guys have played the Kanban game, you can imagine staff liquidity is like the ability to increase the QA's ability to do dev, yeah? So that's one type of swarming. The other type of swarming that we see in some organizations that we like a lot is you find a very interesting problem and you have a temporary team attack that problem. So staff liquidity increases your ability to do that as well. Staff liquidity also can be enabled by using what I call Pareto team stability, which I think is a fun little thing to do. So what you do is you determine the team size, you leave 80% of the team still, and every 6 months you move 20% of the team to another team. So this is moving knowledge as opposed to moving people instead of trying to move information, right? This does two things. One is that you get novel information moves from one team to another. So this guy will bring novel, interesting, new techniques to a new team and say, oh, well, we've been doing it like this over here, right? But the other thing is that when this guy shows up in this new team, these guys will be forced to defend their practices and behaviors to him. So they'll have to re-explain again why they're doing it, which makes their competence conscious competence as opposed to unconscious competence. So it actually increases their ability to do that. So I think that's a useful thing. The other thing is emergent slack. Is a great way of making sure that you get staff liquidity. So emergent slack, when you've got a Kanban system, do not try to get 100% utilization out of your people because it causes lots of problems, which is a whole other talk. But when you have slack, you should reinvest it in staff liquidity activities. So if you've got developers and you see somebody sitting there not working, instead of saying, why aren't you working, say, why aren't you reading a book about the thing that you need to learn? And the interesting thing about reading books, by the way, at work is that they're an interruptible form of work. So it's great for emergent slack because you can basically say to somebody, you're increasing your knowledge, your staff liquidity, that's great, but if we had an emergency, I could interrupt you immediately, right? As opposed to non-interruptible work, in which case you'd be screwed because they would be already involved in something that you couldn't interrupt, right? So using reading and things like that is great. So the other thing that I point out to people when you're doing new product development, this is a kind of the epistemic actions that you can take. And this is a series of life cycle stages in a new product. And it kind of gives you an idea where to look for information, right? So when you first start a new product, you want to determine whether or not something's desirable or not. So a new product or new feature. Your experiments could largely be around that at the start. This is really key because if you can't produce something that people like, they aren't going to come back. You need something that people will at least like enough to start using. So that would be the first set of research. The second set of research is whether or not the thing that you made an effective, observable, perceivable result for the consumer, right? So one is get somebody to use it. Two is make sure they get the result that they expect. And then three is make it repeatable. So the research you would be doing at that particular phase of your product development would be, will people continue to use or convince others to use your product? And then once you've got these three, then you can start doing kind of the more traditional kind of process improvement stuff on your organization, on your product, which would be make sure that you can sustain the effort, and then finally make sure that the product is efficient and therefore making you lots of money. So there's a couple problems I find with with real options that I don't have the solutions for yet, but I thought I would point them out to you guys. And they particularly have to do with the way that we look at Kanban systems, right? So this is a big problem, I think. A lot of people have started talking in the Kanban community, especially about fuzzy front-end Kanbans. So like this idea that there's like a Kanban system that tries to determine what to build and then there's a production cycle. Does that make sense? I think that's really problematic. I think it's problematic primarily because I think most epistemic action requires you to go through the production cycle. So there's no sense, the fuzzy front-end thing doesn't really exist. You still have to produce the work and get it onto production servers. Does that make sense? So the problem, the conflict that we have between real options and Kanban systems is that in order to make a Kanban system appear stable, you need to make sure that you have a two-phase commit. Everybody heard of two-phase commit yet? So first phase commit is that you accept the work from a queue and you say, we will finish this work. And the second phase commit is, we have completed the work, it should go into production now. And so between these two lines, you are committed, you are not optional. And so this causes some friction between these two different ideas, right? So what happens if you've got an option in the middle of one of these systems and you determine that it's not really a good option anymore? If you remove it, it screws with the lead time of the system. So there's, in most Kanban systems, the advice is, again, to do a commitment to completion. So I think, for me, the only way around that is to really think a little bit about, A, making sure that you're constantly reducing this cycle time, and making sure that you're not putting too large of options, your options that you're putting into the system aren't too large. But the second one is to think of your Kanban as a double loop. So you go through twice. And I use Josh's ideas about sufficient design for this. The first loop through your Kanban system should just be a sufficient design. You don't need to have massive amounts of unit testing and lots of production worthiness for your first epistemic testing. You just need it to be you just need to get it into production in a relatively safe way. And then if it works, you need to go back through your cycle again and create production code. Does that make sense? So you want to loop twice through your Kanban, which I think is very confusing for a lot of people because it means that your option is still optional even though it's on your production servers. And that makes most people feel a little bit crazy because we've all been taught this whole done is done idea. And that makes people's like cognitive load go crazy. They're like, but I'm done, it's on the production server. But really what you're saying is, no, that's a test. We need to go back through the cycle again. That makes sense to everybody? That one's a little bit weird, I think. And I don't have the best answers for you yet, but I've been playing with that. So here's some derived principles that you guys can use based on this talk. First is this one, which is the temporal and social distance between relevant information and those making decisions impacts the quality, efficiency, timeliness of those decisions. So in this one in particular, I think is the timeliness stuff. I think if you look at flow efficiency ideas and you look at the idea of like increasing flow efficiency, the amount of time it takes to make decisions in most organizations is directly inverse to the number of hops up the ladder you have to go to make that decision, right? Not only does it make the decision worse, but it makes it take a lot longer. And that alone creates these massive invisible queues of work that are waiting to be completed as you're waiting for someone to make a decision, right? So you get a double whammy. A, you get bad decisions because people don't have access to the information, and B, you get larger cycle times. So distributed decision making enables faster cycle times. Faster cycle times enable more options and therefore less big bets. So one of the things about optionality is one of the ways you get more options is you shrink your cycle times down so you have literally just more frequent option points. So you can decide more frequently whether or not you want to move forward or not. Faster cycle times result in higher quality customer interactions. So this one here is really simple. if you got somebody on the phone talking to you about a problem with your product and it takes you 2 or 3 weeks to put that into production, by the time you call them back, they won't care anymore. But if you're on the phone with them and you say, could I talk to you tomorrow about this? And you push and you can talk to them tomorrow, you get better interactions, right? So you get higher quality software by having shorter cycles. More options, more value, more time, more information. More information and options means better decisions, right? And then I have 2 last slides, and then you guys can ask me questions. One is, these are kind of warnings from Olav and Chris Matz. Real options is not about probability. It's not about figuring out risk based on probability, if that makes sense. So most people look at risks, they have some graph that they've made that says, these are the things that have the highest probability of happening and the highest cost if they happen. We're going to address those things. They focus on those. Real options says that human beings are incredibly bad at determining the probability of a bad event happening, and so you should make sure you have options for almost all events that you identify as being risky. Does that make sense? And that's because real options is about survivability. It's not about probability. Make sense? So these are all the people that I have referenced and talked about in the talk. If you guys haven't read Commitment, this is a great book. It will summarize a lot of the stuff that I said. It's available out at the bookstore. It's a comic book, so you can give it to almost anybody who will read a comic book, and they can read it in a day or 2. It's quite good. Here's some other books that I have used. I love this one, by the way, about risk, engaging in risk, especially the negative behavior involved in positive reinforcement from risk. It's really cool. So that's me, and I'll be glad to answer as many questions as you guys have. Do you guys have any questions? Anybody any questions? 10? Yeah, a lot of information. Thank you. Yes? Yeah, so one of the problems I think with option theory is so there's 2 problems. One, you're talking about capacity, and the other one is the amount of options sometimes causes analysis paralysis, like I have too many things to think about. And the answer for me is the same in both cases, which is, if I go back to here. The ideal thing is that you have enough slack in your system to address as many options as possible at the same time. So you want to be exploring multiple options. But if you don't have capacity, you only have to focus on option 3 because it expires first. Does that make sense? You don't have to care about the other options. Yeah, so I didn't clarify this, but this is one of the key things I think as well, which is, for me, these 3 options would almost always be addressing one particular problem. Does that make sense? Options to me doesn't necessarily mean like I have an option to build a website or have the option to build a car. I have those options, but really it's, I have multiple options to address a single problem. That's where you get the value out of options, right? So that if your problem is how to make money, then you could do like car and website, but it's just the problem's too vague then. Does that help? Yep. So, yep. Yeah, so if you got 2 frameworks, so well, let's just do, we had 3 frameworks. So for me, the way you would use real options in that particular thing is you'd sit down with 3 guys, you say, how long will it take us to implement this framework? Like each of them. Just like, not accurate, but just like, is it going to take like 3 weeks or 5 weeks, right? And then you'd ask them, how certain are you about that? Are you like, how much experience do you have with it, that framework? No experience, lots of experience. I know somebody who knows the stuff. And that would give you this kind of red box. And then you want to choose the option to explore first, which has the greatest uncertainty and expires first. Does that make sense? and explore that one first, because you have limited resources. That's the way to address it. Because what you want to do is buy information. And so you go to the thing that has the most uncertainty in it, because when you convert uncertainty, it becomes information, it becomes the way you make a decision.
So the Pareto team stability
Yep.
concept, so has that worked for you empirically? How did, I mean, someone like this one be taken off one team,
Yep.
put on another?
Yep. So,
Human elements of that.
yeah, there's a lot of human elements. So what I've found when working with people is two things. One, you can't force people to move teams. It's a very bad idea. But if you look around, there will be people who want to move. And if you can, all you got to do is get a pool of them, and then you just make them move around. And they actually like the novelty of it. And they like changing teams every once in a while. So if you can find, it tends to be a good generalist, maybe even an expert, somebody who's pretty high on the 3s and 2s level. And they like moving around, and they like kind of being the new guy who can show people new stuff. And you're just trying to basically take someone who has been embedded in your system in a particular view of it and have them go somewhere else and say, this is kind of how they see it from over there. Does that make sense? The other way you can do it that's lower cost than that is, I call them social brokers. And all you do is you take a value stream of your business. So you got like ops people, you got QA, dev, whatever, right? And if each team has a stand-up every day, you take a member from the downstream team and make them go to the upstream team's stand-up every day. And the result of that is that when there's a problem, the person downstream can talk to their teammates that know them and say they know what the other team's been working on. So they can generally say, like, I think it might be over there. They just did a new database release yesterday, A. And B, if they find a problem that's very specific, they can go, I know the guy who was working on that, and I can introduce you to him in a personal way, as opposed to an abstract, like, Jira ticket flow system thing, right? So that's another way to move knowledge around, is just literally make someone go to somebody else's stand-up and just stand there and listen. It's very valuable. That one's worked really well for me. Other questions? Yes, sir.
Kind of mushy, but so if real options is really all much about information arrival,
Yep.
then how do we also battle sort of like the biases of, like, sometimes the more information we have, the more we're going to codify our bias that we're just going to reconfirmation bias of what we already think we should do.
So I guess I'd point you like towards lean startup and scientific experimentation for how to do the epistemic work, like the knowledge seeking work. And the main thing again is the way that I stated it here is I said safe to fail, which is kind of just scientific principle, right? Like it's just try to disprove your theory as opposed to proving it. So assume that what you're about to do won't work and design the system to consume that, not the opposite way, which is what most organizations do, which is my boss told me to do this, he must be a genius because he's the boss. So obviously I'll build it so that it works that way, right? Other questions? Yes, sir.
Right decisions, uncertainty, and wrong. But isn't wrong also information? So why is that after uncertainty?
Yeah, they commit to being wrong, I think is what I think what they mean, what Chris means by that is they commit to being wrong. So they actually do stuff knowing that they're probably not right. Or in a lot of organizations, you'll see like you walk in and you look and you're going, it's clear that this is not the right thing to be doing. And everybody you talk to is like, yep, this is the wrong way to go. And you go, why are you doing it?
So it's the acceptance of the wrong. As
That's right,
to using
exactly.
it
It's that they, again, it's this idea that they couldn't figure out how to act. They couldn't figure out how to engage in a behavior that didn't have a measurable result that was predefined. So what they did was they said, well, even though that's not the predefined state we want to end up in, at least it's one that we can define, so we'll do it. Other questions? We have 5 minutes. I've tortured you guys for an hour and a half. Thank you, guys.
Thanks, Jabe.